is equal to here answer minus r here by t square d square by 1 square. Correct. அப்படி டேர்ம் வந்து இன்டர்செப்ட் கரெக்டா அவன் என்ன சொல்லியிருக்கான் ஈக்குவேஷன் பார்த்தோம்னா ஆஃப்டர் திஸ் பார்ட் ஆஃப்டர் திஸ் பார்த்தோம்னா y equal to mx plus yன்றது தான் என்னோட ஈக்குவேஷன் m into x.
Online students, can you hear me?
Yes, sir.
You have any doubts from last concept? Composition, number of one and number of onto function. Anybody? Please do let me know if there is any doubts. No doubts, online students? I am waiting for more students to join us.
Sir.
Yes, please.
Sir, can
Some
you
doubt?
explain composition of a function? Sir, I wasn't available in I didn't class.
Full concept again.
No, just like a recap, sir.
Okay. Okay, like give me a minute. Then okay, like recap kind of thing I have here. I'll do one thing today. I think I uploaded notes of inverse trigonometry. You guys have seen that?
Yes.
Response. In Teams, I have uploaded the notes of inverse trigonometric functions. File name is itf_sr01. From what I have started teaching, I think sum and difference formula from that I have given. Let me give you this notes as well. Once you go through it, if you are still having problem, I'll arrange the session for you alone in one day. Is that clear?
Okay.
So any other doubts, other online students? Speak please if you have some doubts.
No, sir.
No doubts. Okay. What about offline students? Any doubts? Yes, in relations functions only. No, that I didn't thought yet. Meanwhile, yesterday I was solving JEE advanced paper as they asked. That's why I was not able to take the doubt class yesterday. So like in that I found a problem from relation and function. I wait like another 5 minutes, maybe if I get more student. That problem is like this. It is asked, not difficult, but you should think in this problem. Without thinking, you cannot solve it. If your relations and functions is really good, then I suggest you to attempt this problem, right? This is a problem, guys, everybody. In this problem, they have given set A is equals to names I didn't remember, but the data I have remember. A, B, C, D, E, F. There are 6 elements in set A. R is a relation, right? R is a relation on set A. Now they want like they have mentioned capital S is equals to set of all relations R. Inside S you have relations R, right? Which contains 10 elements. That means 10 order pairs. Only 10 order pairs you have, or 10 elements you have in that. And R is reflexive and symmetric. We need all such relations R which contains exactly 10 elements or 10 order pairs, right? And again R should be both reflexive and symmetric. So I am giving you 5 minutes to give one attempt of this problem. You guys can see this one, right? Turn off that. So online students or offline students, I have given a problem. This is a problem on types of relations, right? So it is a numerical answer type. You don't have options. So like it is problem from JEE Advanced 2025 paper 1. If your understanding of relations is good, you can give one try. So like S is equals all such relations are defined on set A, which contains exactly 10 elements or 10 order pairs, and R should be both symmetric and reflexive. This much only they have given, right? So now tell me how you will solve this problem. If you are the one who reads the formulas here, who don't know how that formula came, it is little trickier for you to solve this problem, right? Now, going back to the definition of reflexive relation, a relation R is reflexive if there is A in set A, then there should be A comma A in relation R, right? So what I am seeing here, like this relation R will be reflexive only if I have A comma A, B comma B, C comma C, and so on going till F comma F, right? So I am writing here the solution. First I am making the relation R to be a reflexive relation, right? So R will be a reflexive only if R contains, I'm writing in this, all this order pairs, all these elements A comma A, B comma B, C comma C, D comma D, E comma E, and F comma F. So there are 6 order pairs by default should be there in relation R to make the relation R in a reflexive relation. Clear? Now I have, there is a chance for 4 order pairs, right? So after adding these 4 order pairs, reflexive nature won't be disturbed, but I need to make sure the relation should be symmetric as well, right? For symmetric nature, what I am doing, like let us take the remaining order pairs other than these 6. If you see the number of order pairs in set A, you will be having 36 order pairs, 6 into 6. Out of that 36, I wrote 6 in this. Now the remaining order pairs, if we are considering our selections, should be from this order pairs only, right? So the remaining ordered pairs is equals. I am writing all of them, but in this manner I will write. It is like A comma B, and next to A comma B, I am writing B comma A, right? So A comma C, next to A comma C, I am writing C comma A, right? A comma D, and next to A comma D, I am writing D comma A, and so on. Right? The last two, it is E comma F, and then F comma E. There are 30 order pairs in this remaining set, right? So like if I am taking, like listen, if I am taking any 4 out of this 30, that relation won't be symmetric, right? A relation is symmetric if there is A comma B, then there should be B comma A. So like that means this 2 I can take at the same time. Taking 2 AB and BA and keeping in relation R is not making the relation as not symmetric. It is making the relation R as symmetric. Clear? Like that, how many I have? This is like first thing, total 30, right? So this is first thing in that, and then like this is second thing. I'm taking pairwise 2 at a time. There are 30 pairwise I'm taking. There will be 15 in this. Clear? So this is third one and so on, like this is the 15th pair. Out of these 15 pairs, if I'm selecting one pair, I'm adding 2 order pairs. Clear? Or 2 elements I'm adding. Now I need to add exactly 4 to the relation R because they are mentioned R has only 10 elements. Clear? So now exactly 4, if I'm seeing, I need to add 2 pairs. There are 15 different pairs. In 15 different pairs, if I need to take any 2, that is, there are 15 different you have with you. You need to select any 2, that is 15C2. Clear? Select 15C2 now, right? We number of such relations will be equals to 15C2. Out of these 15 pairs, you select any 2 pairs, add to the relation R. That is your relation which is both reflexive and symmetric relation. Answer here is 105. Huh? How many we are taking? If we are taking 3, that is 15C3. If we are taking 4, that is 15C4. We are selecting 2 set out of 15 set. 4 order pairs we are adding, that is 10. Clear? This is 105. Number increased little bit. So this is the problem asked in the advanced 2025, right? So this is what I solved, and then like majority of Akash gave one solution I checked, and then some other institutions also I checked, it is matching. There are some problems as well, but those are a little trickier. 105 only answer. That's all. Solving here will be easier.
Asking N of S, sir.
N of S is 15. No, reflexive, this 6 is pakka, right? We don't have the relation R with us. We are adding this, no, 15C2, we are adding another 4. Now you have a relation R. Like what I am saying in relation R, this one I am writing like inside R you have
6 plus
1 moment, listen. Inside R you have like A comma A, B comma B, and so on going till F comma F. There are 6 order pairs. Now you are adding 4 order pairs, right? So AB, BA, AC, CA, right?
Yes, sir.
So now this is one such relation R, which is containing 10 order pairs or 10 elements and symmetric reflexive as well. Clear? Like this, I can make 105. Clear? 105 such relations. Now, this is about inverse of a relation. Inverse of a function, not relation, sorry. Maybe you guys would have studied matrices and determinants. In matrices, there is something called inverse of a matrix. Can you tell me whether for every square matrix can we find inverse, or inverse exists for every square matrix? Is that true? What is the condition that like for a square matrix A, it is invertible? Anybody? Again, you please listen. I have a square matrix, order 3 matrix, 3 by 3 matrix when we will say a 3 by 3 matrix is invertible, if you studied in your school, you would have known.
Not all the elements are.
Only that one. Anything else you have?
If there are no two repetitions.
Okay, like what you say, what is the formula of A inverse, guys, in matrices? A inverse is equals
1 by
A transpose illa A inverse. A inverse, somebody saying from online, if you studied matrices, what is the formula of A inverse?
1 by determinant of A into adjacent of A.
Adjacent illa, the adjoint of A.
Adjoint of A.
See, like now for any square matrix, can we again I'm asking any square matrix A is there, A be a square matrix of order 3. Can you find inverse for that? What is the reason or what is the criteria necessary condition? When we will say a matrix is invertible, if you studied in school, you will be knowing that. We will say a matrix is invertible if it is a non-singular matrix. If the determinant is non-zero. What happens if determinant is 0, 1 by 0 you have, that is not defined. Clear? That is in matrices. In functions, we will say a function is invertible only if the function is bijective. Clear? Function is bijective, then only inverse exists. Function is not a bijective, inverse does not exist. What is bijective? Both 1, 1 and on 2. So the definition will be like this. Let F
Sir, can you
maps.
scroll up, sir? 1 minute.
Sorry,
Sir, can you scroll up?
you have some doubt in this. Who is speaking? May I know your good name?
Sir, Aditya.
Yes, boss. Tell me, what is your doubt in this?
No, sir. It's cleared, sir.
Clear. So this is the definition for inverse of a matrix, guys. Sorry, inverse of a function, not matrix. Let F be maps from A to B, be a bijective function. If it is not bijective, inverse does not exist. Right? Right? The function F is said to be invertible if there exist G maps from B to A such that G composition F is a identity function. You can also write R. F composition G is a identity function. Identity function na y equals x or f of x is equals to x. F of x is equals to x is an identity function. Same element. What element you give? Same image. Right? So like if you have a bijective function, then that bijective function will be definitely having an inverse. That inverse, like if you are doing composition between G and F, you should get identity function. If it is happening like that, then G is inverse of F. Here, the function G maps B to A is inverse of F. Vice versa is also true. If G is inverse of F, then F will be inverse of G. Clear? Understood? For example, we are taking F of F and G mapping from real to real. You can take function f of x is equals to 2x plus 3 and function g of x is equals x minus 3 by 2, right? So now when we will say, like, if you are doing composition between f and g here, but there is no doubt f and g are bijective functions, right? So linear function, that's when it is bijective. Now if you are doing like f composition g, that is f of g of x will be equals to 2 times of g of x plus 3. We are replacing x with g of x in f of x. This is 2 times of x minus 3 by 2 plus 3. Now we can cancel 2 and 2 here. We have x minus 3 and then plus 3. This is also gone. Equals to x. X is a identity function. When you are doing composition between two bijective functions, you are getting identity. Then the functions are inverse to each other, right? In matrices, you will write this one as like when the product between two non-singular matrices is equals to identity matrix, then both matrices are like inverse to each other. A into B is equals to identity, then B is equals to A inverse. Same thing. F composition G is equals to identity, then G is F inverse. Vice versa is also true. Two-sided statement. Clear? Any doubts in this? Anybody? Online students, any doubts in this?
No, sir.
Done. See, like now we will see the procedure, how we will find the inverse. Some steps will be there. We are finding the inverse. Always remember this line. Inverse of a function exists only if the function is bijective. If it is a non-bijective function, inverse does not exist. Step number 1, check whether the given function is bijective or not. If it is not, inverse does not exist. If it is bijective, then we can find. If y is equals to f of x is not bijective, it is not a bijective function, then f inverse does not exist. We cannot find. There is no f inverse. If it is bijective, then you consider the equation y is equals to f of x, manipulate it. You can use all mathematical techniques and find like x is equals to f inverse y. I need x is equals to a function in f. X is equals to a function in y. If I can do that, I already found f inverse of y. Now what I need is f inverse of x. Now f inverse of x, if you want, for that replace y by x in f inverse y. Therefore the inverse will be, you will get f inverse of y here. Like normally if you have some different function, they'll give you a function. If it is not bijective, there is no point of finding this thing. First check whether it is bijective or not. If it is bijective, in that case you proceed further. If it is not a bijective function, in that case don't do, just write inverse does not exist, right? Maybe I'm taking some basic problems from the book. Previous year JEE Mains problems, 1 or 2 I will solve. Page number 41, there is problem number 85, that is a problem on inverse of a function. Page number 41, problem number 85. There are some problems like from 85 till 89, these are all problems on inverse. Can give one try. So go through the problem once, keep this procedure in your mind. Everybody copied, right, online students?
Yes, sir. Yes, sir.
So page 41, problem 85. This is problem asked in JEE Mains 2020. Function is f of x is equals to 8 power 2x plus or minus 8 power minus 2x divided by 8 power 2x plus 8 power minus 2x. See, like here there is no option saying that inverse does not exist. If there is no option saying that inverse does not exist, no need to worry, right? If there is an option saying that inverse does not exist, in that case definitely we need to check. Now step number 1 gone. Step number 2, we need to assume y is equals to f of x, and then try to solve x is equals to something in terms of y. X is equals to get a function in terms of y. Now this is y is equals to 8 power 2x minus 8 power minus 2x divided by 8 power 2x plus 8 power minus 2x. Let us substitute 8 power 2x is equals to t in this. So y is equals to t minus t power minus 1 divided by t plus t power minus 1. Right? If you know componendo and dividendo, I can do that. If you don't know componendo and dividendo, what you can also do is like cross multiplication. Before doing that, you take LCM. This is t square minus 1 by t square plus 1. Right? So next this becomes y into t square plus y is equals to t square minus 1. So now interchanging y and then what and all, interchanging t square and y. So this becomes y into t square minus t square is equals minus y minus 1. So this is y minus 1 into t square is equals minus 1 into y plus 1. T square is 1 plus y by 1 minus y. So t will be I am not taking plus minus, I am just taking only root, because t is 8 power 2x. 8 power 2x cannot be negative and all. Now 8 power 2x is equals to 1 plus y by 1 minus y whole power 1 by 2. When we are changing sides for 8, exponent 8, it becomes log base 8. When you are changing sides for a in a power x, it will change and it will go log base a. Clear? So here this will be 2 power x is equals to log base 8, and this is 1 plus y by 1 minus y power 1 by 2. I can use the property of logarithm and I can write x is equals to 1 by 4, I'll get 2 from here and then 2 from there. Log base 8, we have 1 plus y by 1 minus y. As I mentioned earlier, you have x is equals to f inverse y. We need f inverse x, so f inverse x is equals to 1 by 4 into log base 8, and we have 1 plus x by 1 minus x. If you see, no option is similar to this. What you need to do is like you need to apply change of base theorem. What change of base theorem says? If you have log a base b, this will be equals to log a base c by log b base c. This is known as change of base theorem in log. We can apply this theorem and then we can write that 1 by 4 into what we can write here. Base 8 is there now, that base 8 we can write as base e there. So this is log of 1 minus x comma. Base e I made 1 plus x by 1 minus x. In denominator we have log 8 base e. So again another property from logarithm I'll use when I have log a base b, this I can write as 1 by log b base a, right? Now in denominator I'll apply this, it becomes 1 by 4 into, I can interchange them by writing in numerator. So this is log e base 8 into, this is log 1 plus x by 1 minus x base is e. This is inverse of the function, that is option number 2. Any doubt in this? Anybody?
X equal to 1 by 4.
No, here it is there, no? From this,
Next is how can we equate f of x? F inverse x.
here, if you see, let me write here. You have an equation x is equals to f inverse y. So this entirely what you have in right hand side is f inverse y. Consider that right hand side and replace x with y. Y with x, if you do, you will get this. This is easy one. Copy this. Next we will see the properties of logarithm of this one inverse and we will solve problems. Maybe I think we can finish even and odd functions. Any doubts, online students?
No, sir.
Everybody copied this. All done. See properties of inverse function. Properties. There are some properties. I think 4-5 basic properties we should see. Property number 1. If F is bijective, then F inverse is also a bijective. It says like inverse of a bijective function only exists, that is also a bijective. If you are doing inverse of a function again, F inverse whole inverse is equals to F. 2 times we are finding inverse of any function, we will get that function itself. Let's say we have G composition F and we are finding inverse for this. It is equals to F inverse composition G inverse. The graph of y is equals to f of x and y is equals to f inverse of x are mirror images with respect to y is equals to x line. For example, e power x and log x both are inverse functions. Like for log x, inverse is e power x, for e power x, inverse is log x. So if you observe the graphs here, the graphs of these two functions are mirror images with respect to y is equals to x. If you draw a line y is equals to x about this line, the points on this graphs are images. Y is equals to ln x, y is equals to e power x. Let's say you know the graph of y is equals to f of x. You need to find the graph for y is equals to f inverse x. In that case, we can take mirror image with respect to y is equals to x line. Clear? Now the inverse thing we will use on onto, right? Normally, domain of f inverse is equals to range of f. This point is what we use. No, for onto. We will find domain f inverse and find domain of f inverse. From there we'll proceed. Now a range of f inverse is equals to domain of f. One more thing I can say. The solution of the equation f of x is equals to f inverse x can be obtained by solving f of x is equals to x and f inverse x is equals to x. See, like if they are intersecting, then that point of intersection can be solved by solving these two equations. Clear? Again, you keep this one in mind. This is not one and only one solution, or these are all not only solutions. We have other solutions as well. Clear? And these are all properties of inverse function. Copied this. So next, like there are some small
Sir,
problems.
1
Yes,
minute,
please.
sir.
Some
Not
doubt?
copied.
Okay. No, I'm just seeing. I hope you guys can do problem 86, 87, 88 and 89 based on this concepts, what we learned. Maybe I should teach one problem on how to find inverse of a non-uniform function. Let's say they have given a non-uniform function. Now we will see how to find inverse. After finishing that, we will go to the next concept. For this, I am taking page 58, problem 6. Page 58, problem 6 I am taking. Can I scroll up, dear students, online students?
Yes, sir.
See, like, go to the page number 58, problem number 6. There they have given a non-uniform function. In this non-uniform function, they are asking to calculate inverse of that, and after taking inverse, there is some value they are asking. Page number 58, problem number 6, right? In this problem, let g of x is equals to f inverse x. So what they have given, function f of x is given to us. F of x is equals to, we have x whenever x is less than 1, and again we have x square whenever 1 less than or equals x less than or equals 4. After that 8 into a root x whenever we have x is greater than 4, right? So like here, greater than 4 only, less than 4 already, right? So now to find inverse, I'm using the concept like, if I do composition between the function f and g, I should get a identity function. For this, I'm replacing x with g of x in the given function. If I do that, left hand side will be f of g of x is equals, right hand side wherever you see x, there you write g of x. This is g of x when g of x is less than 1, and then like you will get g of x whole square when g of 1 less than or equals g of x less than or equals 4, and then like you have 8 into root g of x. This is when g of x is greater than 4. Like, now what I need to do, like what happens to my left hand side here? Left hand side I will get a identity function. Now I am using like case 1. What is case 1? In case 1, listen carefully. When g of x is less than 1, when g of x is less than 1, we wrote f of g of x is equals g of x. We know very well composition between a function and its inverse is identity function. That is x, right? We can say that our g of x is equals to x. Now you have this inequality, no? Solve this inequality as well. And then like for x is less than 1, in place of g of x, I wrote 1. Now in second case, what we need to do in second case, we need to use again same thing, right? 1 less than or equals g of x is less than or equals 4. Now x is equals to g of x whole square, right? So now next this becomes g of x is equals to plus minus root x, right? Now the range of g of x says it is in between 1 to 4. Then it cannot be minus root x, so we are taking root x. Now go to the inequality, substitute g of x is equals to root x and solve this inequality. What we get? We get 1 less than or equals x less than or equals 16. Clear? Now the last case. In case 3, we are taking when g of x is greater than 4. If g of x is greater than 4, in that case, what is the definition? I can write 8 times of root g of x is equals to x. Now g of x will be equals to x square by 64. Right now using this x square by 64 is greater than 4. Now x square is greater than 256, x is greater than 16. Clear? Now I have f inverse of x, or that is g of x. F inverse of x is equals to same as x whenever x is less than 1. Case 1 result I have taken. This is equals to a root x whenever 1 less than or equals x square less than or equals 16. Now the last one, x square by 64 when x is greater than 16. I need f inverse 256 or g of 256. For that, what we need to do? We are substituting f inverse 256 in the function. In this interval only we have 256. We are using that. This is 256 into 256 divided by 64. 64 into 4 is 256, I guess. 16 into 16. Right? 16 into 4 is 64. Right? So this is 1 and this is 4. Now we have 256 is 2 power 8 into 2 power 2 square. Now this one is equals 2 power 10. 2 power 10 is 1024. Now they are asking sum of all the digits of this 7. Clear? Like same way you can find composition as well.
For all cases, we f of g of x equal to x. How can
We see we are doing composition between a inverse and the function. That's when only it is x. Right? Any doubts, online students?
case?
No, sir.
Okay, I'm sure.
So how are we getting 8 into root of f x equals x?
Case 3 means this one. Clear? X is equals to 8 root g of x. Then squaring. 64 into g of x is x square. G of x is x square by 64. Using the inequality and getting the value of x. I will also have an interval x less than minus 16. That is not required here. I already included x less than 1 case. For for same thing, we should not have like 2 different images. If I am taking like that also, it won't be function. It will be just relation. Copy this, please.
Board exam. differentiation integration லாம் தெரியாது.
அப்போ ஒன்றும் இல்லை கொஞ்சம் நமக்கு அறிவிக்கலாம்.
ஆமா. மற்றபடி காம்பினேஷன் பெர்முடேஷன் சிம்பிளா கிடையாது. இல்லை ஃபார்முலாஸே எனக்கு தெரியும். அப்புறம் ட்ரிகோனோமெட்ரி விட்டு வைப்பாங்க. நான் கேட்கணும். அதாவது நான் ஃபுல்லாக தெரியுமா பற்றி டிஃபரன்ஸ் தெரியல எனக்கு. தெரியல எனக்கு இதுதான் அட்டன் பண்ணுற மாதிரி இருக்கு ட்ரிகோனோமெட்ரி. அதுவும் தெரியலங்கிறப்போ ஒன்று நடக்கிறாரு. நிறைய நிறைய கொஸ்டின் ஒழுங்காக பார்க்குறேன். திங்க் மாதிரி நிறையா ட்ரிகோனோமெட்ரி அடங்குற மாதிரி இருந்துச்சு. அதுவும் தெரியலங்க ஒரு மாதிரி
ஒரு சண்டை அது கரெக்ட் பேப்பர்
கொஞ்சம் இன்னொரு பட்சத்தில் ஒரு சப்ஸ்கிரைப் பண்ணுமா?
Just scroll up, no? Done. Cases are done. Then just put no 256. Read the problem. They are asking g of 256. Substitute x is equals to 256. You'll get the answer. Which one?
Before f of g of x.
Take f of x, write g of x in place of x.
f of g of x ன்னு இந்த மூணு பேர்
Hmm.
அப்பனா கேஸ் ஆஃப்டர்
Okay.
இடத்துல f of intersection
Huh?
f of intersection கேம் பண்ணிட்டோம்.
That is g of x da they have given in the problem. See, g of x is equals to f inverse x. Clear?
So one moment.
சார் அவங்கனா
f
intersection g
ரெண்டு ஒண்ணுதான். They have given now g of x is equals to f inverse x. You can write g of x there or f inverse x there. If you want, you replace x with f inverse x. No problem in that. What student think na f inverse x na 1 by f of x they think. That's why only I won't write f inverse x. That is not 1 by f of x. Then we will see even and odd functions today itself. All done online students?
Yes, sir.
So now till this moment what I thought I am again telling, I thought about types of relations and I thought how to solve JE problems. After that we went functions. In functions I directly started with types of functions. 1 1 and on 2, bijective function, number of 1 1 function, number of on 2 function. After that we have seen composition of two functions. After that we have seen inverse of a function and the properties as well. Now we are seeing even and odd. Maybe after finishing even and odd, pending is periodic function and how to find domain and range of a function. If you already there in 11th grade with Akash, domain and range, I'm not going to teach anything new. Maybe if you want, you can attend. But if you are not with Akash in 11th grade, this will help you to find domain and range. That may be day after tomorrow, Thursday. Domain and range and periodic functions. This is even and odd functions. What happened? See, there are in types of functions, we have seen if function is not one, that is many one. If it is not onto, that is into. Now here even and odd are not opposite to each other. There are some functions which is neither even nor odd. There is something called neither even nor odd as well. Function can be even, function can be odd. Function is neither even nor odd. Third thing is there. So now here we will say first is for even function.
It can't be both.
There is one function which is both. Can you tell me a matrix which is both symmetric and skew symmetric?
Arithmetic.
First tell me what is symmetric matrix.
Transpose is equal
A transpose is A. Skew symmetric.
A is equal to minus A.
A transpose is minus A. Right? So there are some matrices which are neither symmetric nor skew symmetric. Right? So now there are some matrix, only one matrix I believe, that is null matrix. You are talking about order 3 matrix A and B. If you want an order 3 matrix, you take null matrix. Null matrix transpose you can write as null matrix. Null matrix transpose you can write as -1 into null matrix. Right? So in functions also there is one function f of x is equals to 0. That is both even and odd. Clear? So first even function. We say a function f of x is even if f of minus x is equals to f of x for all x belongs to domain of the function, in bracket minus x also belongs to domain of the function. If minus x is not there in domain of the function, that cannot be even function. Both x and minus x should be there. Some examples of even functions. All are mapping from real to real. F of x is equals to x power n. Here n is odd, even, n is even. When n is even, that is even function. F of x is equals to cos x. F of x is equals to secant x. F of x is equals to mod x. These are all some basic examples of even functions. What happens for this function? If you replace x with minus x, you will get same f of x. That is even function. Next is odd function. Similar kind of thing. Even function, we can compare this even function, or we can correlate the even function with the skew symmetric matrix. In functions, like I can connect these things because like majority of schools would have taught you about matrices and determinants, right? So like we can start from the composition of two functions. Composition of two functions is similar to multiplication of matrices. Product between two matrices is defined only if number of columns of first matrix is equals to number of rows of second matrix. Now here composition between two functions is defined if a range of first function is equals to range of second function, or domain of second function, less than or equals, I should say, subset or equals. Inverse also, again inverse of a matrix you can compare. Even and odd you can take, correlate with symmetric and skew symmetric matrices, right? Odd function, a function f of x is odd function if f of minus x is equals to minus f of x, -1 into f of x. In some situations, it is easier to prove f of minus x plus f of x is equals to 0. Clear? So now here also for all x belongs to domain, and then like in bracket I need to make sure minus x is also from the domain of the function, right? So now some standard examples we are seeing. In examples we can take f is mapping from real to real. F of x is equals to x power n. Here n is odd. And then like all trigonometric functions except cos and secant. So sin x, cosecant x, tan x, cot x. These are all even functions, odd functions in their respective domains. Clear? So now before going properties, we will see like there are some trickier problems where it is difficult to prove that f of minus x is equals to minus f of x. That problems we will see, and we will see the properties. Right. So like we need to check whether the given function is even or odd. So the function here I can say f of x is equals to log x plus root of x square plus 1. This is the function given. We need to check whether the given function is even or odd. To check any given function is even or odd, we need to use the replacement property. We need to replace x with minus x, right? So let's say we are replacing here the variable x with minus x. Now we will be having f of minus x, right? So let us write how much is f of minus x. We will get f of minus x is equals to log of minus x plus root of x square plus 1. See here it is not so easy to conclude it is equals to f of x or minus x. So in this case, I will add or subtract depends on this. So like first I am adding here, if I add that f of x plus f of minus x will be equals to, this is log of root x square plus 1 plus x plus log of root x square plus 1 minus x we have. Like now this is log a plus log b that we can write as log a into b. So this is log of x square plus 1 plus x into x square plus 1 minus x we have with us. Now there is a plus b into a minus b, that is a square plus b square. We get log of x square plus 1 minus x square. This 2 got cancelled. We have log 1. Log 1 value is 0. So therefore I can write that f of minus x is equals to minus f of x. This implies the given function f of x is odd function. Yes, please. Just I interchanged x and x square.
Second termல logல வந்துட்டு
Hmm.
அந்த bracket குள்ள இருக்கிறத மைனஸ் காமன் எடுத்து 2 ஆகிக்கலாம் செகண்ட்.
Minus you cannot take like that outside log. Log of minus a is not equals to minus log a. Not possible. We cannot move minus inside and outside. Logarithmic function is neither even nor odd. There are no negative numbers in log domain, right? If I want to prove a function as even, I need to prove that f of x is equals to f of minus x. Both x and minus x should be there in domain. There is no negative numbers in the domain, right? That cannot be a even or it cannot be a odd. Any doubts in this? If you copy this one quickly, we will finish the properties today itself.
Done.
Yes, sir.
Properties of even and odd functions. In properties, property number 1. You have seen similar statement in matrices. Any function maybe in bracket you write neither even nor odd. Can be expressed as the sum of even and odd functions. What does this mean? You would have learned, no? Any matrix can be expressed as sum of symmetric and skew symmetric. Same thing. Now let's take f of x is the function. For this f of x, we write this f of x as f of x by 2 plus f of x by 2. Now we are adding for first one, like maybe you write this is 1 by 2 into f of x plus f of x. Now inside the bracket we are adding f of minus x, we are subtracting f of minus x. This is 1 by 2 f of x plus f of minus x, right? Plus f of x minus f of minus x. Now separate this one. This becomes f of x plus f of minus x by 2. This part is known as odd even thing. This is the even part of that. Next is f of x minus f of minus x by 2. This part is odd. You can check that. Based on this property, they asked a problem in JEE Mains in the year 2019, I guess. Copy this.
That step.
Which one?
That step.
This one.
All three.
Adding, subtracting. Same thing is allowed, no?
Yes, sir. Can we do the same for f of x equal to 0?
Not require f of x equals 0. I can write as f of minus x is equals to plus minus f of x. Anyway, 0 only. That's why it is both even and odd.
Sir,
Yes, please.
sir, won't this be valid for even and odd functions too?
I didn't understand.
Sir, won't this relation be valid for even and odd functions too?
If the function, any function, I think it is. Not necessary it is even, not necessary it is odd. If it is even, I have taken some random f of x, right? So what I did, I wrote multiplied and divided by 2. That after that I added and I subtracted f of minus x. Any function. It is not necessary that it is even, not necessary that it is odd. Can be any function.
Sir, but by definition, it should be neither even nor odd. No?
No, we will use this one in neither even nor odd case. You can write
Okay.
sin x as sin x plus sin of minus x by 2. That part over there is even part, right? And then next part is there, no, sin x minus sin of minus x. That part is odd part. Clear? You simplify it, you will get even that's there sin x only. That is odd function. Clear?
Yes, sir.
We will
Understood.
use this property when we have neither even nor odd. I am not saying we cannot use for even or we cannot say use for odd. We can use.
Okay, sir.
Okay, boss. Done.
Sir.
Second property. Even functions are symmetric about x is equals to 0, that is y axis. Symmetric means mirror image with respect to that line. Odd functions are symmetric with respect to y is equals to minus x line. Same thing they will also write in opposite quadrants. Or they'll also say about origin. Here I can add one point. If the function f of x is odd and 0 belongs domain of the function, then f of 0 should be 0. Listen, if it is an odd function, then f of 0 should be 0. If f of 0 is equals to 0, then the function may or may not be odd. Odd, we are talking about odd. Clear? Keep this one in your mind. We don't know whether 0 is not there in the domain, what you will do. We can see that like f of minus x is equals to minus f of x. Put x is equals to 0, you will get f of 0 plus again f of 0 is 0. Function is odd, then f of 0 should be 0. Clear? So next about f of x is equals to 0 is the only function. You can call this one as 0 function, which is both even and odd. Now I have a doubt. Can even functions be 1-1 functions?
Yes, sir.
Justify your answer why yes.
Only images.
Think again. If f of x is even, perfect. If f of x is even, then f of x is many one function. It cannot be 1-1 function. For example, you take function f is mapping from real to real. F of x is equals to x square. It is even function, right? Now you can see now f of minus 1 is equals to f of 1 is equals to 1. any one function. Clear? There is a table alone pending. I think in day after tomorrow's class, I'll explain about the table. F and G two functions they'll give. What I'll get if I add them, if I subtract them, if I multiply them, divide them, composition. Different situation, both even, one odd, one even, both odd in that case. That is the last one we are going to see. Right? Any doubts in this? Maybe one more point I can add here. This is about composition. We will see in the table. If f of x is even and g of x is any function, then g composition f, that is g of f of x, is even. This is true even though g of x is even, g of x is odd. If the composition we are doing, in that case, the inside function should be even. If it is even, then it is even, right? So g, we don't know, g of minus x may or may not be equals to g of x. But what we know that f of minus x is equals to f of x. Now we use this. G of f of minus x will be equals to g of f of x, right? Clear? This implies g of f of x is even function. Clear? Copy this. Loose connection or what? Dear online students, any doubts in these things?
Sir, last point alone can you explain again, sir?
Last point is like, it says if there are two functions f and g, in that f is even, g may or may not be even, right? In that situation, when we are doing composition, we will get even is what the last point claiming. Like, in order to understand this, listen carefully. If means they have given in that. So we are writing like a proof kind of thing. Since f is even function, f of minus x is equals to f of x. This is the equation number 1. Now replacing x with minus x in g of f of x. So g of f of minus x will be equals to what I should write from this equation 1, f of minus x becomes f of x. Clear? So like what I proved here, I proved like a function h of minus x is equals to h of x. This implies that function is even function.
Okay, sir.
Think Shiva Ganesh, I think just text me in WhatsApp today. I'll give you the notes for composition of two functions.
Okay, sir.
Go through that once. Still you are not able to get it. One day I'll arrange a session for you.
Okay, sir. Thank you, sir.
Okay. Thank you for attending this session. You guys can leave. Offline guys can go for break.